Hi, welcome to our statistics and quantitative analysis class. This is session number 2, and in this particular session I'm looking at statistical measures. To be specific, I'm looking at measures of dissipation. In our session 1 of our statistics classes, we had looked at the measures of centrality, where we considered the mean, mode, and median, and how to calculate those three measures of centrality. In this particular video, we move on and look at the second measures, which is the measures of dissipation. Measures of dissipation. Now let's explain what measures of dissipation are. Statistical dissipation means the extent to which a numerical data is likely to vary about the average values. In other words, dissipation helps us to understand the distribution of data. So we've got a number of measures of dissipation. These are the measures that helps us to understand the spread within the distribution given. So types of measures of dissipation, we basically have two different types of measures of dissipation. We have the absolute measures of dissipation and the relative measures of dissipation. In our Zika syllabus DA2 and CA 1.2, we only focus on the absolute measures of dissipation. So these absolute measures of dissipation, these are measures of dissipation that expresses the variations in terms of averages. The variations are expressed in terms of averages, and we have the following types of measures of dissipation. Number one, we've got the range. The range is simply the difference between the maximum value and the minimum value in the distribution. You are given a set of data or a distribution of data. The difference between the highest value in that distribution and the minimum value in the distribution is going to be your range. And then we also calculate the second type of measures of dissipation is actually the variances. There is quite a good relationship between the variances and the standard deviations. The standard deviation is simply the square root of a variance. So you can use the standard deviation formulas, just remove the square root to calculate your variances. And once you get your variance value, you can simply square root that, and that will convert the variance value to a standard deviation. So standard deviation SD is simply the square root of a variance. The square root of a variance. A variance probably will be demonstrated as q squared, because a variance is the standard deviation squared. The standard deviation squared will be a variance, but standard deviation is the square root of a variance. Then we have other types of measures of dissipation, such as the quartiles and the quartile deviations. The quartiles, these are values that divide a list of a distribution into quarters. And the quartile deviation is simply half the distance between the third quartile and the first quartile of the distribution. So Q3 minus Q1 divided by 2, that will be the quartile deviation. Interquartile range will just be the difference between the third quartile and the first quartile of the distribution. So you get the Q3 minus Q1, that will give you the quartile deviation, the interquartile range. But the quartile deviation is also the same as the semi-quartile range. That's the quartile deviation. You have to divide the difference by 2. Apart from that, we also have other measures of dissipation, such as the mean deviation. In our study on the measures of central tendency or measures of centrality, we had looked at the mean, which is just the average of the numbers, and we say the mean is simply the sum of the numbers you have or values that you have divided by how many those values are in the distribution. An arithmetic a mean deviation is going to be an arithmetic mean of absolute deviations of the observations from the measures of central tendency, which is known as the mean deviation or an absolute deviation. All right, now having said that, I want us to look at an example. This example is gonna focus so much on the calculation of standard deviation. In another video I will do examples on the calculation of the mean deviation, but this particular example is coming from the CA final exam paper for June 2018. This is the CA 1.2 paper. Question 4 was a question on statistical measures, to be specific, measures of this patient, such as the standard deviation. So let's look at the question 4 of this paper. Question 4 of that question paper, there it is. This was CA 1.2 June 2018 exam, and that was a question 4. Question 4 says a sample of 25 local companies had the following percentage change in output over the past 3 months, and we are given the percentage change in terms of output and the number of companies. So the data here is about the percentage change in output. The number of companies will represent the frequency. Remember, we had defined what a frequency is from our area video, where we say the frequency is simply the number of times each of those values is appearing in the distribution. And in this case, we have the frequency as the number of companies, and the actual data we are looking at is the percentage change in output. So we're given a grouped data. Again, as you are listening to this video, you have to make references to the earlier video that I did, which is the session 1 video. It explained the difference between a frequency distribution and a simple set of values, and also how to deal with the measures when you are given a grouped data. So we have a grouped data here, and the questions are as follows. Required: estimate the mean percentage change in output. We had learned on how to calculate the mean. The mean is simply the sum of the values divided by the number of values. But because we are given grouped data, the mean is going to be the sum of fx divided by the sum of f. You're going to see how we are going to demonstrate that calculation. The second question there is saying calculate the standard deviation of the above data. Standard deviation of the above data. Standard deviation, as we have already said, it's simply a measure of dissipation, measuring the spread of the data within the distribution. Another thing that I should mention at this point before we even begin to calculate is the fact that this standard deviation measure can also help us to calculate the variance measure, because we know the relationship between standard deviation and the variancy, that standard deviation is simply the square root of the variancy. And if we have standard deviation and we want to convert it to a variancy, we just say standard deviation squared. That will give us the variance value. And we can also look at the coefficient of determination, which is going to be the standard deviation of mean. We are going to demonstrate that part as well. So the other question, explain how you can calculate the median for this data. Now, we had dealt with this part when we looked at the first session in statistics, measures of centrality or measures of central tendency. You can calculate the median either by constructing a cumulative frequency distribution, and you measure the 50% of that distribution, or you can use the formula. This was also demonstrated in the earlier video, so you can make references to that particular video. State the model class. We're gonna pick the model class, but we had already said that mod is simply the value that has got the highest frequency. So when you look at the distribution like this one, you can just look at which class has the highest frequency. Of course, looking at the frequency column, which is the number of companies, you'll find that the highest frequency is 8, and so the model class is the class with that highest frequency, and the class will be 4 to 6. So in this particular question, our major concern here is the calculation of standard deviation. So let's have our worksheet. So what you need to do when you're given a question like that is just transfer the data on your answer sheet as you begin to work out these such equation. So looking at this data that we're given, and the solution is going to be worked out on the right side. So right side, we're dealing with the solution. On the left side, we have the equation. Okay, so on the left side, we have the question. This is question 4 of 2018 junior exam. So what you need to do is transfer data first of all on your answer sheet. So you have the percentage change. This is the percentage change. That's the data we are given there, and it's grouped data. So we have 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. All right, then put up the frequency. Of course, the frequency is given in terms of number of companies. So we have 3, 4, 8, 7, and 3 as our frequency. Now, two things I'm going to calculate from this question is the mean, which is calculated using the formula summation of fx over the summation of f, and then we're going to deal with the standard deviation, which is given by the formula down there, standard deviation formula. Now let me explain something about this standard deviation formula. This standard deviation formula is used for grouped data or frequency distribution. There is another formula for standard deviation of a simple set of values. I'm going to tackle that probably in our next video. But this is the standard deviation formula for grouped data or frequency distribution. Now, on the formula, look at the denominator summation f minus 1. Summation f minus 1. The reason why we have a summation f minus 1 is because the data is a sample. If you look at the question is saying this data we are given here is for a sample. Check there. This is a sample of 25 companies, a sample of 25 local companies. This is the sample. What could have happened if the data was a population? If the data was a population, in this formula we are going to remove the minus 1 from the denominator. So it's going to be that formula divided by summation f. If it's the population, you can't have summation f minus 1 for a population. It's simply divide by summation f. The reason why we have a minus 1 on the formula is because the data is for a sample. All right, and many questions that will be given on this one will state whether the data is a sample or not, or they'll give you clues that will tell you that this data is a sample or it's about the population. If it's about the population, don't do the minus 1 from the denominator. All right, so having said that, we can go to the actual calculations. Now, in your solution, you're going to create a table. The columns you have in your table depends on the things that you really will be required to calculate from the question. For example, we are asked about the mean, so we need the summation of fx. So we need to have our column called fx. That's a column fx. The reason why that column fx has arisen is because in our mean calculation we need the summation of fx, and in our standard deviation calculation we also need the summation of fx. So we need to calculate those values for fx. All right, now this other one, fx squared column also arises because the standard deviation formula will require us to calculate fx squared there. Now, if data is given as grouped data, for you to get the x value, you need to get the midpoint of the groups or the classes. And we did this in our earlier video that we did on statistics measures of centralities. You need to get the x value. The x value is simply the midpoint of the classes that you are given. So for instance, we have our first class, which is 0 to 2. So you will say 0 plus 2 divided by 2, that will give you 1. So the x value for that particular class is going to be 1. The x value for the second class, which is 2 to 4, is 2 plus 4 divided by 2. That's going to be 3. That's our x value there. So 4 plus 6 divided by 2 is going to be 5. Our 6 plus 8 divided by 2 is going to be 7. And our 8 plus 10 divided by 2 is going to be 9. So we have our x values, which is 1, 3, 5, 7, and 9. Our cumulative frequency only arises if we are measuring the median value. Arises if we are measuring the median value. So in this particular table, I included the cumulative f because there was an explanation that needs to be done on the calculation of median. But for a standard deviation and the mean itself, we can just proceed to fx. So let's get the fx. Fx is simply the f value multiplied by the x value. So the first one is 3 multiplied by 1, you get 3. The second one is actually 3 by 4. So 3 multiplied by 4, you should get 12. 3 multiplied by 4, that's going to be 12. The next one is 5 multiplied by 8. So 5 by 8 is going to be 40. The next one is 7 by 7, that's 49. The next one is 9 by 3, 9 multiplied by 3, that's going to be 27. So fx is simply the f value multiplied by the x value. So once you have worked out the x value, which are just midpoints, the frequency, of course, will always be given. So multiply the midpoints by the frequency, you will get your fx. Now, how do we get the fx squared? There are two ways you can get the fx squared. Firstly, you can take the fx and multiply it by x. That is going to give you the fx squared. Or you can first of all square the x values and then multiply those x values, squared x values, by the frequency. It's going to give you fx squared. So this is simple mathematics that we did at primary or secondary school, where fx squared would mean f multiplied by x multiplied by x 2 times. Since we have the f by x, we just multiply that by x again. That is going to give you fx squared. So what we are having here is 3 multiplied by 1. This 3fx multiplied by 1, which is that x value. We have our answer as 3. Then we take this 12 multiplied by 3. What is 12 multiplied by 3? That should be 36. 36. And the next one is 40 multiplied by 5. What is 40 multiplied by 5? That should be 200. The next one is 49 multiplied by 7. 49 by 7, 343. The other one is 27 multiplied by 9. 27 multiplied by 9. That's, 27 multiplied by 3. We are multiplying by f, not the x. So 27 multiplied by 3, that is going to be 243. 27 multiplied by f3, that's going to be 243. Let me just go through this one again. 3 multiplied by x1, so 3 multiplied by x1, and then we have 12 multiplied by x3, and we have 40 multiplied by x5, and we have 49 multiplied by x7, and we have 27 multiplied by x9. So we are multiplying by x because we have fx multiplied by x. That's going to give us the fx squared. So the next thing you need to do here is to get the summations. In our formulas, we need the summation of f. So summation of f, we add up all the f values, 3 plus 4 plus 8 plus 7 plus 3. The total there, the sum, is going to be 25. So summation of f is 25. We get the summation fx. Summation fx, that's the 3 plus 12 plus 40 plus 49 plus 27. The summation there should be 131. We get the summation of fx squared, 3 plus 36 plus 200 plus 343 plus 243. That should give us 825. 825. So we have our summations here. We have our summations. So summation fx squared, summation f, and summation fx. So those summations are done. So let me just put those summations in bold. After doing that, we can then calculate the value of the mean. It is simple. Once you've got the summations, the rest of the work is simply placing those values into the formulas and calculating the required values. So this is going to be equals to, summation fx is already calculated. So summation fx is 131, and summation f, we've already calculated that. Summation f is 25. So 131 divided by 25, 131 divided by 25, that should give us 5.25. So 5.25 should be the answer that you get after dividing 131 by 25. Mean done. Now let's look at the standard deviation. The standard deviation, we need to place those figures into the formulas. So placing the figures into the formula. This is a formula for standard deviation for a sample. Remember, we are looking at the sample. That's what we are dividing by summation of f minus 1. So this is going to be equals to, we replace those symbols with the values. So the value of summation fx squared is already calculated. Summation fx squared is 825. So put 825 there. 825 minus 825 minus summation fx squared. Summation fx squared. So you get 131 multiplied by 131. So what will be the value of 131 multiplied by 131? Summation fx is 131. So get your calculator, do the 131 multiplied by 131. That's the 131 squared. That value is going to be 171.61. 171.61. Alright, so that's about 17,161. 17,161. That value must be divided by the summation of f. Summation of f is 25. So divide that value by 25. Then everything divided by the summation of f, 25 minus 1. So you have 25 less 1. That should be the denominator. So that working, putting those values into your calculator, you must have something like this. putting those values into your calculator. Everything here on top is going to be your 17,161 divided by 25. 17,161 divided by 25, so 161 divided by 25, that's gonna give you 686.44. so 686.44, that's the value that you're going to have here. Then summation fx squared remains 825. Then the denominator here, 25 minus 1 is going to be 24. So working out everything there, finding the square root for those values, your answer should be, after everything is worked out, your answer should be the square root of 5.664. So when you get the square root of that, you'll get the standard deviation as 2.38. 2.38 is going to be your standard deviation. Remember what I explained on the relationship between standard deviation and the variance. So if you want to get the variance, in this case the variance is going to be that standard deviation squared. Sorry, that the square of that standard deviation. So variance, let me just work it out there. So variance in this case is going to be 2.38 squared. 2.38 squared. So 2.38 to the power 2. And when you do that, 2.38 to the power 2, your variance value should be 5.664. So you get 5.664. That should be the variance, at least approximately. So in this particular video, we had only focused on how to calculate the standard deviation for grouped data, and also looking at the relationship between the standard deviation and the variance. The other thing that you can be asked here is how to calculate the coefficient of variation. So we at first I mentioned the coefficient of determination. Coefficient of determination is calculated when you're looking at the correlations, but when you're looking at the standard deviation in relation to the mean, you calculate the coefficient of variation. So coefficient of variations, which is the COV, coefficient of variations, COV is going to be equals to the standard deviation divided by mean. The standard deviation divided by mean. So let's just insert a simple formula there that can help us to work out this one. So we are away from that data, we can make this one a little bit big, insert something there. So the coefficient of variation, COV, is the standard deviation divided by mean, and this is expressed in form of a percentage. Standard deviation divided by mean, that's the coefficient of variation. So coefficient of variation, according to our workings in this question, the coefficient of variation should be, what is our standard deviation? Our standard deviation is 2.38. Our standard deviation is 2.38 divided by our mean for this distribution. The mean for this distribution is 5.25. 5.25, that's the mean. So our coefficient of variation is going to be 2. Actually, that one you multiply by 100, so this is going to be 2.38 divided by 5.25. That will give you 0.45 times 100%. So 0.25 you multiplied by 100%. This is going to be equals to about 45.33%. 45.33%. That's the coefficient of variation. So among the list of measures of dissipation, we have the range, the standard deviation, the mean deviation, the variances, and the coefficient of variations. So in this particular video, we've looked at the standard deviation and its relationship with the variances, and the calculation of the coefficient of variation, which is expressed as standard deviation divided by mean times 100%. I'll do another video that will look at the other remaining measures of dissipation. That's the mean deviation and the quartiles. So mean deviation and the quartiles will be presented in another video, and how to calculate expected values will also be presented in another video, where we'll look at another way of dealing with standard deviations when you are given probabilities instead of frequencies. So when you are given a probability distribution, there is another way we calculate the standard deviation that will also be demonstrated in another video. Thank you for your time. Please look forward to the other videos that I'm going to do on statistics. That is, if these videos are of help to you. Thank you.